Hey guys, we're going to cover 11.6 polar coordinates. Polar coordinates are new. It's different than what we've talked about with rectangular, which is traditional X and Y, where you move left, right, up, and down. Polar coordinates, you move in a more like along a hypotenuse rather than horizontal side, vertical side. Here's an example of what a polar coordinate looks like. Kind of looks like a web, very different than what the XY coordinate plane looks like. But let's kind of relate this to what we already know. The middle here is where you would find 0, 0 on a typical plane. This is called the pole, P-O-L-E, kind of like the North Pole. Instead of traveling to point A by going right and then up, we would just do a direct path basically on the hypotenuse. Okay, so we can just go like straight line, shortest distance. So it's actually a more efficient way to travel using like polar movements. Okay, so first thing we're going to look at is naming points rather than an XY coordinate. We're going to use polar coordinates where we use R and theta. R represents, you could think of it as radius. It's going to be the distance that you are from the pole. And each one of these rings represents 1 unit away. Kind of like if you ever cut a cross section of a tree trunk, you can count the rings for how many years. Kind of similar. Every ring is going to be 1 more unit away. And then we want to talk about theta, which is the angle that we're traveling. Lucky for us, these angles as we go around increase in the counterclockwise direction. 0 straight out to the right, 90 is straight up, 180 is straight to the left, just like our unit circle. This one has more denominations than just what the unit circle had. You see we have like 15, 45, but essentially it's going to work the same way. On the right, we have the radians, again, very similar to how our unit circle operates. Okay, so the first thing we're going to do is name some coordinates. I'll kind of color code this a little bit. So let's do point A, and I want to name that r comma theta. We can count that that's going to be from the pole. It's 1, 2, 3, 4 rings away, so it's 4 units from center. And that's at an angle of 60 degrees. So I'm going to call that 4 comma 60 degrees. Point B is going to be 1, 2, 3 units away, and that's at an angle of 210 degrees. Now we'll switch to radians. So point C over here looks like it's 5 units away at 3 pi over 4. And then lastly, point D is 2 units at 3 pi over 2. Okay, so that's in a nutshell how you can name these points. Now we're actually going to look at 3 other ways to name these points. So let's look at point A. I'll do A and C, and then I'll leave the other ones for you guys to try. So point A. Imagine that we always, as a default, aim towards 0 degrees, and then we need to rotate until we're looking where we want that point to be. And then we're going to throw the point. Think like we're throwing a ball. So I want to rotate this to 60 degrees, and then I launch 4 units away to get to point A, right? Now we know from coterminal angles, I could also rotate in the negative direction and aim at 60 degrees that way. So essentially what we can do is I can say 4 comma and then find a coterminal angle with 60 degrees. Let's subtract 360. That's going to get me to negative 300 degrees. That'll land at the same spot. Now I'm going to introduce the idea of a negative radius. So you'll notice we had positive radius, positive angle, positive radius, negative angle. Now I want to have a negative radius with a positive angle. And how we achieve this is, let's stick with that idea of facing 60 degrees, then kind of tossing a ball forward. Well, another way to land a ball at point 8 would be to stand at the center here, at the pole, face directly across the circle, like towards 240, and instead of throwing the ball forward, throw it backwards over your head. So I'm going to aim at 240, but I can throw it backwards over my head 4 units away, and that's going to result in coordinates of -4, 240. That's still going to land me at the exact same point of point A. All right, I aim, this angle is where you're aiming always. And then negative just means you throw it backwards. And then lastly, let's do -4, and let's find a negative coterminal angle with 240. So I subtract 360, and I get -120. So if you look at all the red, I have positive, 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 negative, negative, positive, negative, negative. And we always want to follow that pattern to name these points in 4 different ways. You could come up with an infinite number because you could keep adding 360 or subtracting 360 to change the angle. Let me do a radian. We'll do point C in green. And I want to name that point 3 different ways. So we were at 5, 3 pi over 4. I think the easiest way to find your next one is do 5, comma, and then subtract 2 pi from 3 pi over 4. Basically finding a negative coterminal. So subtracting 2 pi, this would be the version of 2 pi because I want common denominators. So that's going to give me -5 pi over 4. Okay, now I need to talk about my -5 for a radius. And let's see, let's aim across the circle from C. So if I actually aim at 7 pi over 4, throw it backwards over my head 5 units, that'll land at point C. So backwards over my head, again, is the -5 radius. So to achieve that, I would have to aim at 7 pi over 4. And then for my last one, I'm just going to subtract 2 pi from 7 pi over 4. And that gets me -5, pi over 4. So go ahead and try. Oh, I'm sorry. These should all be going down here for point C. Can you guys try point B and D? You can check the answer key that I posted. So go ahead and pause it, and then I'm going to move on to the next page. All right, next we're going to talk about how we can convert from rectangular coordinates, which is x, y, to polar coordinates, r, theta, and vice versa. So we've already used kind of all the tools that we need for this. So first I'll go polar to rectangular. So again, polar means I'm starting with r, theta. And I want to change that to what we're more familiar with, x, y. So I need to find x. I need to find y. X can be found by doing r times cosine of theta. Y can be found by doing r times sine of theta. And this is really just kind of rearranging some of our equations from SOHCAHTOA. So if you want to try to figure those out, you can. But again, the result of this is going to be x, y. I'm solving for x, solving for y. Next, we'll go the opposite way. So let's say we have rectangular, and I want to go to polar. So I have x, y. I want to find r, theta. So I need r. This is our relationship to find r. I can use basically the Pythagorean theorem. R squared equals x squared plus y squared. And if you square root both sides, you're going to get r equals the square root of x squared plus y squared. That was kind of like what we did with our complex numbers when we were looking for the absolute value. It's really the same idea. We're just existing in a different universe, so we have different names for it, but the equation is essentially the same. Likewise, if we're going to find the angle theta, I want to do inverse tangent of y over x. This is just like what we did with complex numbers finding theta when we did b over a, same thing as y over x. And the only thing you need to watch out for is make sure you're in the correct quadrant, right? Maybe you'll be looking at a reference angle when you do that calculation. Just convert it so that you're in the correct quadrant. All right, so I'll do a few of these. Let's take a look at number 1 here. I'm converting from polar to rectangular. So I'm going to rectangular. So my answer should be x comma y. And you can tell you're looking at r theta because you have 30 degrees, right? And if there's no degree symbol like down here on 3 and 4, those are obviously radian measures. So just be careful on the calculator. And these could be calculator problems or non-calc. If they're non-calc, then it's guaranteed to be unit circle angles or an angle like -150 that you could easily turn into a unit circle angle. So x here is going to be 4 times cosine of 30 degrees. Y is going to be 4 times sine of 30 degrees. And I don't have a unit circle on me. I'll just do these as calculator. 4 cosine of 30 gets me 3.46. 4 sine of 30 gets me 2. So don't just leave it like this. Let's write the coordinates. We're going to be looking at 3.46 comma 2. All right, let's do a radian measure. So again, looking for x and y. So x is going to be 2 times cosine of negative pi. I think I might do this one non-calc. I don't want to think about a negative angle, so I'm going to add 2 pi to this. So that actually just becomes positive pi. Y is going to be 2 times sine of pi. Cosine of pi, that's over at 180. That's going to be -1, so it's 2 times -1, which is -2. My sine at pi is going to be 0, so it's 2 times 0, which is 0. And that's going to get you coordinates of -2 comma 0. You can try 2 and 4. I'm going to move down and do a few of these, and then we'll be done. So now I want to go the opposite way. I'm staring at x and y. I know that because there's no degree symbol, and it's telling me that's what I'm looking at. So this is x comma y. I need r comma theta. So again, r, we can do essentially Pythagorean theorem. I'm square rooting both sides before I write it. So this gets me what? 4 plus 4 is 8, and then that's under the root. I'm simplifying that quickly. And then theta, I'm going to do inverse tangent of -2 over -2. That fraction is really 1, so inverse tangent of 1. That occurs at a 45, but let's think about what quadrant I'm in. -2, -2. That's down here. So I need the 45-degree reference angle down in quadrant 3, which is going to be 180 plus 45. That's 225 degrees. Let's specify here. Let's go ahead and put these in degrees since I didn't tell you which one to do. So 2 root 2, or I guess you could leave it as square root of 8, comma 225 degrees. Last one we'll look at. I probably should have graphed number 5 beforehand, or really any of these beforehand. Let's look at number 6. When I graph this, remember this is x comma y, so 0, 3. We're talking about that point there. Now you can do the calculation for r, you can do the calculation for theta, but I think we can also use logic. I know exactly how many units away that is. That's an r value of 3. It's clearly 3 units straight up, so r is 3. My theta, when I'm straight up, is just 90 degrees. You can do inverse tangent, you're going to find the same thing. So very simply, this will be 3 comma 90 degrees. So sometimes you can save yourself a lot of time. Number 5 took me 2 or 3 minutes. Number 6 took me maybe 30 seconds. So those can be valuable seconds when you're on a quiz or a test. So just keep that in mind. I'll let you guys do 7 and 8. Don't forget that the homework is attached to your notes, and a key for these notes and for the homework is posted on the calendar. Have this done for Wednesday so you are not behind on day 2 of Polar. Thanks, guys. Take care.